Hello everyone and welcome back. In this lecture we'll build our multi-layer perceptron model. So first we'll build a simple multi-layer perceptron model and then we'll add more layers to our simple model. I just copied this from our previous lecture. So these are the libraries that we need to import. In addition to that, we will also need to import stochastic gradient descent SGD. So to import that from Keras that optimizers import SGD. Okay, now that we have imported the libraries that we need, we'll first need to define and specify some values that we'll use for our layers, for our various layers. We'll first start to initialize batch size and number of epochs for our perceptron. So we'll set the batch size to be equal to 128. So this will be the number of samples in each batch. Okay. And then another one is number of epoch, and we'll set that to be equal to 2. So this will be the number of times our model will update the weight. Okay, we'll see where all of this will be used when we build up our model. And for activation, we'll use the Sigmoid activation function. So let's initialize that also. Activations is equal to Sigmoid. Another value we need to initialize is number of classes, NB classes, and we'll set that to be equal to 2. So I'm using the same naming that you'll find in the Keras documentation. So I'm using those NB underscore epoch so that, I use the same naming as in the document. So if you have to go and read more about it in the Keras documentation, it will be easier to identify. Okay, next, we'll convert our yTest and yTrain classes into this number of classes. For that, we'll be using this nputils. It has a method known as toCategorical, and we'll use that to convert our yTrain and yTest into two classes, two forms. Let's do that. So for our yTrain, we'll save it in a variable called yTrain, and we'll take nputils and then we'll apply the toCategorical method. Then we'll pass our yTrain. This method accepts two attributes, two values. So we pass yTrain and number of classes, NB classes, that we define here. And let's do the same for our yTest dataset. yTest is equal to nputils toCategorical. Let me change this to yTest and number of classes. Okay, next, for our model, we'll be using the sequential model. The sequential model is a very common model in Keras. So the first thing we need to do is instantiate our model. And we'll save our model in a variable called model. Then we simply type sequential. So now our model is instantiated. Once we instantiate our model, the next thing we do is add a dense layer, and then after that we will add an activation unit, and that activation unit will be Sigmoid. Okay, so to add a layer, we simply call the method add. We'll use the method or function add on our model, and then we simply pass dense and pass the number of neurons. For our first layer, let's pass 512, and then this dense also accepts input shape, and then we'll set the input shape to be equal to 784. Remember, our sequential model accepts a pixel of 784. That's what we did in the previous lecture. Now that we have added a dense layer, the next thing we need to do is add an activation unit of Sigmoid. For that, we'll say model.add and then pass activation. and we'll use Sigmoid for activation. Okay, so for this first sequential model, we'll keep our model very simple. So we have our input data, and then next what we'll define is our final output layer. Okay, so we'll first add a dense layer by calling the add method on our sequential model, and then this time we'll pass number of classes. So this is our final output layer, and then we will add an activation unit of softmax in this case. I'll explain why. So model.add, then activation, then pass softmax. So for our final layer, we only need to pass our number of classes. So when you pass NB classes, it means it's the final layer. So it will automatically take the output of your previous layer. Okay? So in your last layer, you don't need to pass number of neurons and then input shape like this. So once you specify this number of classes, it will automatically take the output from your previous layer. Okay? And for activation here, we used softmax. When we use softmax, it gives us a list of values between 0 and 1. And those values will add up to 1. That's why we use softmax for our final layer. Okay? So every time in our final layer, we'll use this softmax activation. What the softmax does is, it first adds your evidence and then converts that evidence into probability. So later on, we can calculate accuracy based on that probability. So in our example, we're trying to accurately predict if a digit is 7 or not, right? So what this softmax does is, it will check if your input is in the class 7 or not, and then it will convert that into probability. That's why we always use softmax as our final layer of activation. Next, we have our stochastic gradient descent, and we'll set it to be equal to SGD, and then pass, let's use a learning rate of 0.1 and use default values for the remaining parameters. Okay, so LR is learning rate, and if you don't pass it, it will also use the default value for the learning rate. And what we'll do next is, we'll apply the compile method on our sequential model, and we do this before training. Okay, so this compile method is used to configure our learning process. Okay, let's do that. So we take our model and then apply the compile method, and this compile method, it takes 3 attributes. It takes loss, optimizer, and metrics. Okay, let's pass those attributes. We'll set the loss to be equal to categorical cross entropy. So this is one example of loss. You can read more about it in the documentation, but we have other kinds of loss like hinge loss and so on, but you can read more about it. Okay, and during our model, this is what we want to reduce. We want to reduce or minimize our loss. And then the second attribute is optimizer. So for optimizer, we'll pass our stochastic gradient descent, and this is our learning method. So we use this optimizer to minimize our loss. And then the last attribute is metrics. And for sequential methods, for sequential models, we want our metrics to be accuracy. So again, the compile method, this is compile. The compile method takes 3 attributes. It accepts 3 parameters: loss, optimizer, and metrics. And this is where we configure our learning process. Next, we'll use the fit method to train our model. So we'll call the fit model, the fit method on our sequential model, and then pass our training datasets, X train and Y train. The other attributes the fit method accepts are number of epochs, batch size, verbose, validation data, and so on. So let's pass those one by one. So we'll set the batch size to be equal to batch size that we defined at the beginning. And we'll set the number of epochs to be here, this number of epochs. So we have batch size equal to batch size, number of epochs, and then there's another attribute known as verbose, and we'll set that to be equal to 1. And the last thing we need to pass is our validation data. There's an attribute known as validation data, and we'll be validating what? Our X test and Y test datasets, right? Okay, once we configure the learning process and once we train our sequential model with our X train and Y train datasets, so this will take some time. So here we have train on 12,565 samples, validate on 10,000 samples, which is our validation data, right? And our number of epochs is 2, right? So our first epoch, during our first epoch, loss was 0.56 and accuracy was what, 84.6%. And during our second run, our loss is 0.41 and accuracy is 92%. So this is the function of optimizer. The optimizer tries to reduce the loss. So as you see here in the second epoch, the loss is less. And let me show you the method that we will use for evaluating our model. It's called the evaluate method. We simply call the evaluate method on our model and then pass your X test and Y test datasets, and we'll set the verbose to be equal to 0. And we can save this in a variable called score. Okay, so if we print score, we get 2 values. So what are these 2 values? This tells us the entropy and this tells us the accuracy. So we can index and print this separate. So we can say print score index 0, run it, and then we can also print score index 1. Or we can even add, let's say, accuracy and then score 1. So we have an accuracy of 94.36%. And this first score tells us what the entropy is. Okay, so this is our first simple multi-layer perceptron. Okay, let's summarize what we did in this lecture. Once we imported the libraries that we need, we instantiated some values like batch size, number of epochs, activations, and number of classes. And then we converted our Y train and Y test into binary categories. After that, we instantiated our sequential model. And once we instantiated our model, we added a dense layer and then we added an activation unit of Sigmoid. And for our dense layer, it accepts 2 values. The first value is number of neurons and the second value is your input shape. And then we added another dense layer, which is our final output layer. And we passed number of classes. So when you specify this, it means it will automatically take the output from your previous layer. And for our final output layer, we use an activation unit of softmax. And we say that softmax converts your evidence into probability so that it can add up to 1. That way we can easily calculate or predict accuracy, right? And then we defined our stochastic gradient descent for our optimizer. And we call the compile method on our model which we used to configure the learning process of our model. And this compile method, it accepts 3 parameters: loss, optimizer, and metrics. And for optimizer, we use SGD as a learning method, and we use this optimizer to minimize the loss. And for our sequential model, we use accuracy as metrics. And finally, we call the fit method to train our model with the training datasets. And here we passed additional parameters like batch size, number of epochs, and then we were validating it against our X test and Y test. So later on, when we call the evaluate method on our model, we got an accuracy of 94.4%. So this is a simple example. In the next lecture, we'll look at some more examples and see the result that we get when we increase, let's say, the number of epochs, or change the batch size to a bigger number or a smaller number, and what if we add more hidden layers. And again, check out the documentation on Keras about sequential model. You can read more about it there. Okay, thank you everyone, and see you at the next lecture.